Chapter 13 is about experiments and observational studies. In the last chapter, we talked about basically surveys and then how to sample people to be included in the study. So this is a new type of collecting data. So we'll start out with, there's a lot of definitions here in the next couple of pages, and that's the objective for this video. What's the difference between an observational study and an experimental study? Two different kinds of studies for this chapter. Observational study is basically where the researcher simply observes what's going on. Simple as that. We just watch and record. So the researcher observes what occurs. There's two different types of observational studies. We can have a retrospective study or a prospective study. Retrospective, retro, is basically where you find the subjects and you look at prior data. You look at data that already exist. So you're looking back into the past. It's historical. So you find your subjects of interest that you want to use in your study, and then you use prior data from these people, or data that's been collected. I guess an example of retrospective study is if, I guess this would happen a lot with baseball statistics. You find, look at maybe baseball stats for the past year or 10 years or whatever you're interested in, and, given some people that you're interested in studying, you'd go back and look at the prior data and see what their performance was like. On the other hand, prospective study is looking, basically it's into the future. You find the subjects you're interested in for your study, and then basically you collect new data as time progresses. So you're actually observing them, but then collecting, it's not historical data, but you're collecting new data on what you're interested in. So we want to say collect new data as time progresses. So whether the study is retrospective, looking back, or prospective, looking forward, it's always observational. So the involvement of the researcher is just to watch and record. There's no interaction and no involvement other than that. On the other hand, experimental studies are studies where the researcher is involved. The experimental study, it's a designed study by the researcher, carefully designed study, to determine the effect of some treatment applied to a group of things or a group of people. So it's a designed study, and we're going to learn how to design it properly. So a design study to determine the effect of a treatment. Okay. There's a lot of different parts to the experimental study. Basically, the researcher is going to have some type of explanatory variable that they're interested in. The explanatory variable is modified or altered in order to create different responses for the experiment. So the researcher will manipulate these variables at different levels. These are called factors. Manipulate the explanatory variable levels, or factors, and this creates different treatment levels. An example of this would be like in a medical study on a new drug. You would have different dosages, perhaps, for the different treatment levels. Alright, the second part, you randomly assign subjects to different treatments or treatment levels. So you want to use randomization. It's very important. You take everything in the study, or every subject or person in the study, and you assign them a different amount of treatment. We'll talk about some examples as we go. Finally, once the treatment has been applied, you look at the results of that treatment. So then you compare the responses of the subjects across the treatment levels and get the results of your experiment that way. Okay, so two types of studies: observational study, experimental study. Alright, there's a lot of vocabulary in this chapter. Again, kind of like last chapter. We'll just go through the next couple pages of that. Alright, we've already used some of this language, but first is experimental units. Basically, these are the things or the individuals that we're going to apply the treatment to. So experimental units are the entities, let's say, could be things or people, on which we impose a treatment. So they're the objects of our study, I guess. What do we call them if they are human? They're called subjects. Levels within the experiment are the specific values or the amounts that the experimenter will choose for a factor. So let's get that written. Specific value or amount that the experimenter chooses for a factor. And if you remember from earlier, the factor is just a level of an explanatory variable. So the example would be like dosage of medicine. So you might try an experiment where 3 different levels of treatment are applied, like 10 milligrams of a drug, 20 milligrams of a drug, 30 milligrams of a drug, to see how each dose would work. Okay, the next thing about experiments is design of experiments. And there are 4 principles of experimental design that are important. 4 principles that we use to make sure that we're designing an experiment properly. Just like with a survey design, we had to be careful about bias in surveys. You have to be careful about bias in your experiments as well. So, first one is control. Control refers to making the experiment basically the same for everybody, except treatment. Treatment is going to vary by person, but you want the experiment itself to be the same for everybody. So we want to make this experiment as similar as possible for subjects at each treatment level. So we have to take steps that'll reduce the effects of outside factors, or we'll call them extraneous variables. So you have to control other sources of variation that are not in your study as much as you can. So we control other sources of variation to prevent them from changing or affecting our response variable. We want our response variable to be changing just based on our own controlled treatment levels. We don't want it changing or to be affected by other factors that are outside of our experiment. It's a tough thing to do, but we have to think about it up front so that we can try to control that. The next piece is randomization. And we already know that randomization is important in surveys, and randomization is something that we have to deal with as far as getting results from simulations or any kind of study that we do. We have randomization in play. But in this case, randomization in the experiment refers to the practice of using chance methods, let's say, to assign subjects to treatments. We have to assign subjects to treatments in a random way. So let's say chance methods. So you could use a random number table to assign people, or you could use, like assigning people with a roll of a die if you have it, if that gives you enough variety. Anyway, any chance method to assign subjects. Basically, what this helps us to do is to take out the potential effects of unknown or uncontrolled sources of variation. Okay, we'll continue on page 2 on the next video.